All right, in these worked examples, we'll be looking at questions 39 and 40 related to radioactivity. Question 39 reads, a nucleus of sodium-21, will give you the nuclide symbol, 21 nucleons, 11 protons, the atomic number is 11 for sodium, decays to form a new nucleus containing 10 protons and 11 neutrons, okay? So I kind of want to immediately draw that out as a reaction. So we have a nucleus of sodium-21, and so I'll use that nuclide symbol there, sodium, and it decays into a new nucleus that contains 10 protons. And if it's got 11 neutrons, then that's still going to add up to 21. Okay, so one of these protons, 11 plus 21. So we've got a proton that became a neutron, right? Because this accounts for all of them. So this number doesn't change. It's just we switch one of these for one of those. And so what is the case where a proton becomes a neutron? That's where it's easier for me to kind of look up at the chalkboard and go, which one of those neutron becomes a proton or proton becomes a neutron? Well, since the proton number is going down, right, that proton became a neutron. So we've got, this is an example of beta plus decay. The other way to just sort of think about it very mathematically is, here's 11, 10 plus positive 1. You say, well, what's a thing that has no nucleons and a charge of positive 1? So, you know, you might think a proton, that's the thing with the positive 1, but it's a nucleon, right? And it would change this number. So what actually is happening is the positive charge is due to the positron. This is beta plus decay, positron emission. That's the antiparticle of an electron. You only get one antiparticle per reaction. If you already get a positron, you get a plain old neutrino. The symbol, you know, nu bar, so this is the Greek letter nu with a bar on top, that would be the antineutrino. This question is asking us about the leptons that are emitted. The leptons that are emitted. So remember, leptons are things that do not interact via the strong nuclear force. So not the things in the nucleus, but things like, yeah, electrons, its antiparticle, the positron. So positron is good. Positron is good. Nope, it's not an electron, right? That would be beta minus decay. So you sort of eliminate choices C and D because it's not electron, it's positron emission. Only one fancy antiparticle per reaction. So you say, there's my antiparticle. It's got to have a plain old neutrino. So you should have got B for 39. There's your positron. There's your neutrino. Question 40 says, a neutron decays to form a proton. Neutron decays to form a proton. Which particle is not involved in the decay process? So this one we have, let's just write it out. A neutron, so that's a nucleon, but it's not a proton. Neutron decays to form a proton. And again, mathematically, you'd say, well, what do I add to 1 to make it 0? I got to add -1, right? 1 minus 1 is 0. What's something that, again, this is already balanced, the nucleon number. So what is something that is not in the nucleus? It's not a nucleon, has a charge of -1. That's a good old electron. So when a neutron decays to a proton, we emit a beta minus particle. It says which particle is not involved in the decay process. And so if we get a plain old electron, right, that's where we get the fancy antineutrino. So an antineutrino is involved in the process and therefore not the correct answer to this question. It's asking if one is not involved. Oh, look, on the chalkboard, I mentioned the Quark models, right? There's a way to sort of write this as what's happening to the subatomic particles, the familiar protons, neutrons, and electrons, you kind of see here. But there's a Quark model. Remember that we had a learning objective related to which particles are fundamental. Well, the leptons are fundamental, like electrons and neutrinos, fundamental particles that cannot be divided. But neutrons and protons are made up of the constituent quarks. So quarks are the fundamental particles that sort of do interact via the strong nuclear force. They are hadrons. And so we need to consider a Quark model. So I'll sort of write them out. You have a down, and an up for a neutron, but a proton is an up, and a down. And so what changed is that one of these downs flipped to an up. And when that happens, so if the rest of the reaction is true, it's like, this is really what's happening at the quark level, but you still get your beta minus particle. These are one and the same, right? So writing an electron, beta minus particle, that's sort of the same thing. And then the anti-electron neutrino. So which one is not involved? Okay, the down quark is involved. The up quark is involved, right? The positron is not, because it's not positron emission like we saw in question 39. It's just regular beta minus decay with an electron. So you do get the antineutrino when you get that. So the correct answer for this one has to be C. So you should have got B, C for 39 and 40. This has been a radioactivity paper 1 review.